Hey! Mansi was in the middle of a chemistry experiment in her school lab when she realized the distilled water was over. She thought of using tap water instead. But her teacher stopped her, saying that we cannot replace distilled water with tap water. Distilled water is extremely pure. In fact, it is so pure that it does not even have the essential minerals like calcium or magnesium, which are normally present in tap water. Distilled water is obtained from a process called distillation. Let's see how tap water is distilled using this technique. Let's pour some water into the distillation flask and heat it till the thermometer reads 100 degrees Celsius. At 100 degrees Celsius, the water starts boiling and changes to the gaseous state, leaving behind all the impurities. The purified water now passes through a condenser containing cold water. This causes the vapor to change or condense back to the liquid state. This pure water in the liquid state is collected in a receiving flask and tada! We have distilled water ready to use. Distillation is used to separate different components of a liquid in a liquid mixture. If we heat a mixture of acetone and water, since the boiling point of acetone is 56 degrees, it converts to vapor before water does. The vapors of acetone are then condensed and acetone is collected in a receiving flask. Thus, we can say that distillation is a process of heating a liquid-liquid mixture to boil one of its components, like acetone, and then separating it by condensing its vapors. But what if the boiling points of the components of a mixture are very close to each other? For example, 100 degrees and 110 degrees. Can distillation be used in such a case? No. If we subject such a mixture to distillation, by the time we condense and collect one liquid, the other component will boil and get mixed with the first one. In such cases, we use another type of distillation called fractional distillation. Let's compare the apparatus of fractional distillation with the simple distillation. Everything remains the same, except we have a fractionating tower or column and multiple receivers here. The fractionating tower consists of glass beads which offer an increased surface area for the vapors to cool down. Fractional distillation has a variety of applications, one of which is obtaining petroleum or diesel from crude oil. Let's see how that happens. Crude oil is heated and its vapors pass through a fractionating column. Different components separate out according to their boiling points. Liquid petroleum gas or LPG separates at around 25 degrees Celsius, followed by gasoline, naphtha, paraffin, diesel, fuel oil, lubricating oil, and lastly, bitumen, which is used as coal tar. Thus, when the difference between the boiling points of the components of mixtures is less than 25 degrees Celsius, we use fractional distillation, whereas simple distillation is used to separate mixtures having well spaced out boiling points. Now that Mansi has a clear idea of distillation and its types, she has to go finish her experiment. See you next time.